Good evening, children. So as I told you, we are going to start quadratic equations, nothing but first chapter. Yeah, listen. So in our previous class, we have discussed about what is constant, what is variable, term, expression, algebraic term. You all remember that? Just I am telling them again briefly. So constants are nothing but fixed values. That's why they are representing with variables. No? Representing with variables, right? No, numbers. So constants are represented with numbers because they are fixed values. Number of days of a week, number of months in a year. These are some examples for constants. So that's why representing with numbers. Variables. Variables are nothing but letters. They are not fixed values. There is a variation in their values, like the temperature of a day. While you are observing from morning to midnight, there are different temperatures we have. Am I right? So morning like less temperature, the temperature will be increased like that. Again it is decreased. So there is no particular or fixed temperature in a day. That we can take it as an example for variable. So they are represented with letters. So X, Y, Z, A, B, C, etc. And both combinations, constants, variables combinations, like 2 into X with multiplication symbol or forms the terms. Okay, na? Only numbers you can take, or only letters you can take, or their combination with multiplication symbols are called terms. Okay, na? 2x is a term, 3y is a term, only 3 numerical term number can take. Only number, no? Numerical term we can take. Only x, it is a term. Their combinations are called terms. Like terms, algebraic term means which contains letters. Now expression. Expression is nothing but single term or a combination of terms. Very, very important. Single term or combination of terms with plus or minus symbols is called an expression. Single term or combination of terms with plus or minus symbols is called an expression. So from this we are saying that plus and minus symbols are separating the terms into is combine the terms. Okay, na? Right. Now this is the introduction. We already, I think I already gave you, right? So directly coming to quadratic expression. Quadratic expression. Right. An expression is in the form of X square plus bx plus c. An expression is in the form of ax square plus bx plus c is called quadratic expression. Now, while you are observing that the quadratic expression with variable x, but all are thinking that sir a, b, c are also letters. No, they are also called variables, right? But in this expression, these are called constants, arbitrary constants or coordinate constants. Here a, b, c are called arbitrary constants or coordinate constants. So that all you are writing here. A, B, C are belongs to. Here C means set of complex numbers, or you can take R also, real numbers. Okay. So in your textbook it is given that C. This symbol we know that belongs to. It is looking like E, but not E. That symbol is belongs to. C means complex numbers. Complex number is nothing but combination of real and imaginary numbers. C means complex numbers, nothing but combination of real and imaginary numbers are called complex numbers. Okay. Now, why it is quadratic equation? While you are observing this expression, its degree is 2. Degree 1 expression is called linear expression. Degree 2 expression, quadratic expression. Degree 3, cubic expression. Degree 4, biquadratic expression. Okay, na? Sir, what is degree, sir? So here ax square plus bx plus 3, it contains 3 terms. In every term, in first term we have the variable x and its exponent is 2. So degree of the first term is 2. Second term also we are having x is a variable and there is no exponent here. That means it will be 1. Here second term degree is 1. There is no x term in third term. So its degree is 0. Nothing but x power 0. As you learn in exponents and powers topic, anything power 0 is 1 except 0 power 0. Okay. Anything power 0 is 1. So here its degree 0. Here 1. Here 2. What is the highest one among 3 terms? Highest degree term is ax square, first term. So that highest term, the highest degree only considering as degree of this expression. Okay, na? Degree of this expression. So examples we can take 3x square plus 5x plus 6. Okay, na? Quadratic expression. An expression is in the form of ax square plus bx plus c is called quadratic expression, where a, b, c are called complex numbers or coefficients. Here a is x square coefficient, b is x coefficient, c is constant term or coefficient term of x power 0. Okay, children? Right. Now coming to equation. Now we are just discussing about quadratic equation. Quadratic equation means an equation is in the form of ax square plus bx plus c equal to 0. When an expression with equality sign becomes equation. An expression with equality sign becomes equation. Now, quadratic equation we want. So, quadratic expression with equal to sign. Quadratic equation. Okay, na? If you want to write the definition. An equation is in the form of ax square plus bx plus c is equal to 0 is called quadratic equation, where a, b, c are complex numbers. Here in this equation they are coefficients. These are coefficients. Okay, children? Yeah. Now, So until then, quadratic expression completed, quadratic equation also completed. Now, I told you already linear equation, right? Linear equation means an equation with degree 1 is called linear equation. Degree 2 equation is called quadratic equation. That means here if you take any equation, 3x plus 5 equal to 0. This is an example of linear equation where x is the variable. For this equation, if you draw this equation on a straight line, on a graph sheet, it will give a straight line. So if you take any linear equation, draw it on graph sheet, it always gives a straight line. Okay, na? So we can take it as graphical form of linear equation. Graphical form of linear equation is straight line. You know straight line, right? Now what is quadratic equation graphical form? Graphical form of quadratic equation in one variable. In one variable is parabola. Is parabola. You know the straight line, but what is parabola? This shape is called parabola. We can take like this also. You will have the parabola topic in intermediate, okay? So this shape, it is looking like union and intersection. U shape, right? This is the shape of parabola. It can be in both the ways, this shape and this shape. But if it is having in this shape, it is called minima. It is called minima. This shape is called maxima. That is minima and that one is maxima. Okay. Sir, when these shapes will form, sir? Can you identify any difference in the quadratic equation? Obviously, the quadratic equation general form we know that ax square plus bx plus c equal to 0, where a greater than 0 will give this shape, first one, minima shape. If a value is less than 0, a value is less than 0, it is in the shape of maxima. Okay, children? So minima and maxima, here a should not equal to 0. Remember, the condition is a does not equals to 0, because if a becomes 0, 0 into x square, first term becomes 0. First term becomes 0 means still we have bx plus c. Bx plus c, which equation? Very good. Linear equation. It is in the form of linear equation. Then it won't be a quadratic equation. That's why a not equals to 0. B and c can be equals to 0, because highest degree term should not be 0. If highest degree term is equals to 0, then it degree becomes 1. Okay, na? If you want to write, just write it. Linear equation, its graphical form gives you the straight line. Quadratic equation, graphical form will be parabola. There are two different types of parabolas are there. When it is possible, in the general form ax square plus bx plus c, nothing but x square coefficient is greater than 0, you will get minima, and a value is less than 0, you will get maxima. This shape is called parabola. Okay, na? Next, pure quadratic equation. I am writing shortcut QE, okay? QE means quadratic equation. Pure quadratic equation. Pure quadratic equation means if you observe the general form ax square plus bx plus c is equal to 0, if b becomes 0, that type of quadratic equation is called pure quadratic equation. Okay, na? Example, 3x square minus or plus 5 is equal to 0. We have x square term, constant term. There is no x term. So x term becomes 0 here. This is called pure quadratic equation. Okay, na? Any examples you can take. 7x square minus 49 equal to 0. Here also x square term is there, constant term is there, but there is no presence of x term. So x term is absent here. So we can call it as pure quadratic equation. Okay, children? Quadratic expression, quadratic equation, and its general form, graphical form of linear equation, straight line, graphical form of quadratic equation, parabola. Again, two different shapes, minima, maxima. When minima will form a value, nothing but x square coefficient is greater than 0, minima. X square coefficient is less than 0, maxima. Okay, na? Very good. Now, pure quadratic equation is one of the type of a quadratic equation. Next, monic. Monic quadratic equation. Monic quadratic equation. Monic quadratic equation means the x square coefficient. X square coefficient means what here? A. X square coefficient becomes 1. That is called monic quadratic equation. Example, x square plus 7x, x square plus 7x plus 3. There is no coefficient of x. That means coefficient of x square is 1. Here x coefficient is 7. Constant term 3. What are the coefficients here? There are 3 coefficients. X square coefficient not there anything means 1 will be. X square coefficient 1, x coefficient is 7, and remaining constant term is 3. 3 coefficients are there in the term. Okay? Please note it. Any other doubts, children, until here? Constant variable you already learned in the previous class, that's why I am not going to deeply in that topic. So quadratic expression, equation, and these concepts, types of quadratic. 2. Pure monic. Next one. Yeah. So here you can identify that linear degree 1, quadratic degree 2, cubic degree 3. That means the solution of linear equation degree 1, no, the solution is 1. That means there are one root. Root is nothing but solution of that equation. Okay. Quadratic degree 2, no, there are 2 solutions. For quadratic equation, there are 2 solutions, nothing but 2 solutions means the x value will be 2 different answers. X value will be 2 different answers. Okay. They are called roots of quadratic equation. roots of quadratic equation, or we can call roots are zeros. Zeros of quadratic equation. Roots of quadratic equation are zeros of quadratic equation. Why it is called zeros? For which value the given equation becomes zero, that value is called zero of the equation or root of the equation. Okay? Zero of the equation or root of the equation. So here quadratic equation, how many roots we have? Number of roots of quadratic equation. Now only I said number of roots of quadratic equation is 2. If the number of roots are more than 2 different values, there 2 roots means 2 different values. Okay. Number of roots of quadratic equation is 2 different values. If you get more than 2 different answers, then that quadratic equation become identity. That quadratic equation become identity. That is all I am writing here. If a quadratic equation have more than 2 roots, it becomes an identity. Got it, children? According to degree, there will be number of roots. Cubic equation, degree 3, number of roots also 3. Biquadratic equation, degree 4, number of roots or number of zeros also 4. Okay, no? So in case a quadratic equation having more than 2 different roots or distinct roots, distinct is nothing but different only, different roots, it is become an identity. Okay? Yeah. Next, I think you all have written this, am I right? Or else it just take a screenshot. Can I go for next one? Yeah. Now finding the roots. So I told you that there are 2 roots for a quadratic equation. For finding the roots, in this chapter we have 3 different methods: factorization, quadratic formula, and complete square root method. Completing the square method. Okay, na? From the completing square method only, we are using, we should find out a formula. That is the derivation part. Okay, na? Clear? Yeah. So before that, let me tell you that if you know this symbol, right? Alpha. Alpha and beta are roots of an equation. If alpha comma beta are roots of a quadratic equation, what is that quadratic equation? Ax square plus bx plus c, that is equals to a into x minus alpha into x minus beta. that is equals to a into x minus alpha into x minus beta. How it is coming like that for getting the sum of roots to product of roots? Let us see that. A I am leaving like that. These two bracket terms, it is a binomial, it is also binomial. Now multiply with it. X into x. X into x how much? X square, am I right? Yeah, a into x, these two. X square. X into b. X term is positive, beta term is negative. X into beta minus x beta. Now with x, I multiply these two terms. Now with minus alpha, I should multiply those two. Minus alpha into x minus x alpha. Okay now? Minus into minus plus alpha into beta becomes alpha beta. Okay now? I just multiply this. That is equals to a into x square. Once observe these two terms, children, middle terms, both containing the x as a variable. I am taking minus x as a variable. So minus x if I have taken common. Here beta remains, here alpha remains. So beta plus alpha. I am writing in an order alpha plus beta plus alpha beta. So this quadratic equation continues like this. So previously I have taken alpha comma beta are roots, right? Alpha comma beta are roots. I already told you what are roots. Roots are zeros. Roots are nothing but solutions, okay? Or zeros. Ax square plus bx plus c. Now this a, I am transposing this side. Here a is multiplying. When we transpose this side, it becomes divides. Now this will be ax square by a. It divides each and every term. Okay? That is equal to, it is already transposed this side. Still we have remains only bracket terms. That is equal to x square minus alpha plus beta into x plus alpha beta. Compare coefficients of each term. X square term is having, x term is having, constant term also having. Here also x square term, constant term. Now I am comparing the x square coefficient. X square terms, x terms, constant terms. X square term here, both cancelled. Numerator and denominator cancel. X square coefficient 1. Here also x square coefficient 1. Okay, I am leaving it same. Now here x coefficient what? Minus alpha plus beta. X coefficient what? I am writing here, compare x coefficient and constant terms. So x coefficient what here? Minus alpha plus beta. Here x coefficient, what is it? X coefficient, except x remaining term, b by a. Okay na? So minus of alpha plus beta is equal to b by a. That's it. I am writing minus of alpha plus beta equal to b by a. From this I can write alpha plus beta is equal to minus b by a. Very, very important. So sum of roots is nothing but minus b by a. Now constant terms. Check the constant terms here. Constant is alpha plus beta, alpha into beta. Here constant is c by a. Alpha beta equal to c by a. So simply we can write alpha plus beta means addition. Alpha beta are roots, very starting we discussed. So I can write sum of roots. Sum of roots equal to minus b by a. That means minus b means what? X coefficient. A means what? X square coefficient. This is the formula. Sum of roots equal to minus b by a. Next, alpha into beta means what? Alpha 1 root to beta 1 root. Both are adding means sum is coming here. Both are multiplying. So product. Product of roots equal to c by a. C means what? Constant term. A means x square coefficient. Okay na? Sum of roots minus b by a. Formula you should remember. Sum of roots equal to minus b by a. Product of roots equal to c by a. Now see one example here only. Just 3x square plus 6x plus 7 equal to 0. For this equation, sum of roots. What is alpha plus beta? Minus b by a. That means minus x coefficient. X coefficient means 6 by x square coefficient. X square coefficient means 3. Answer is minus 2. Because 3 table in 6, 2 times minus is there, minus 2. Alpha plus beta. Same way, product of roots, alpha into beta. Alpha into beta means what? Constant by x square coefficient. Constant is 7. X square coefficient is 3. 7 by 3. That's it. Sum of roots, product of roots. Very, very important. Okay, children. Just revise the concept. So today we discussed about. Please note it. Please note it. Or you can write here, compare x term, constant term also. Got it, children? Yeah, once see the concept what we have discussed today. Yeah. For some basic information, constant, variable, term, expression. Quadratic expression. It is in the form of ax square plus bx plus c, where a, b, c are complex numbers. Okay, na? If this expression is equal to 0, becomes quadratic equation. Next, we are discussing about linear equation also. Degree 1 equation is called linear equation when it is drawing on a graph paper. It will be straight line. It will give you the straight line. Now coming to quadratic equation, its graphical form is parabola. Very, very important. Parabola. This shape. Minima, maxima in the conditions of a greater than 0, a less than 0. Next. Types of quadratic equations. Pure, monic. Pure means x term should be 0. Monic means x square coefficient always 1. That's it. Next. Roots of quadratic equation. That means for which value the given quadratic equation becomes 0, that value is called root of the quadratic equation or 0 of the quadratic equation. Okay, na? You are substituting one value in the term in the place of x, then answer is 0. That number is called root of the quadratic equation or 0 of the quadratic equation. Okay. Number of roots of quadratic equation is 2. according to the degree I told you. Linear equation 1, quadratic 2 roots, cubic 3, biquadratic 4 roots maximum. If a quadratic equation get more than 2 different roots, it will become an identity. Not only quadratic, anyone. You are getting more than, for example, cubic you are taking, more than 2 roots you are getting. Sorry, more than 3 roots, 3 distinct roots. That is also become an identity. Next. Proof of sum of roots to product of roots. For this I am taking like this. This is taken from factor theorem. In 9th class you will learn about it. If alpha is a root or 0 or solution of an equation, x minus alpha is its factor according to factor theorem. Okay, you know in I think in 9th class you know polynomials topic, factor theorem or remainder theorem and all. Okay, right. So from this I am deriving like this. Finally I got sum of roots is minus b by a, this one. Sum of roots minus b by a, that means minus x coefficient by x square coefficient. Product of roots is c by a, constant term by x square coefficient. Okay, na? Any other doubts, children? You have to check thoroughly this one, concept and all. Okay, yeah, that's it for today, children. I'm going to wind up the class. We'll meet you in next mathematics class. Thank you, one and all.